Hello students and welcome to another video. I'm your teacher Mr. Flynn, and today we're going to be doing a video on percent by volume, percent by mass, and parts per million. So I'm going to go through all of these problems. Now when we're thinking about concentration, there's more than one way to calculate concentration. Before, in previous videos, we've talked about using molarity, all right, moles per liter, but in this situation we're thinking about how much of our solute is in the solution based on a percentage, okay? Now, a volume, we're thinking of liquids. Like in this example, we're using ethanol, okay? And the one down below, we're looking at mass. And when we're looking at mass, we're probably working with something that's solid being dissolved in solution, all right? So our units will be be used differently when we set it up, but it's the same kind of premise, okay? So let's go through and let's just talk about this example. So the question is, what is the percent by volume of ethanol in the final solution when 75 milliliters of ethanol is diluted to 250 milliliters with water? So the volume of the solute, which is a liquid, which is ethanol, is 75 milliliters. Okay, and then the volume of the total solution is 250, because that's what we diluted our ethanol to, is 250, right? So we had 75 milliliters of ethanol, and we added a whole bunch of water to get to 250, and we want to know what is that percentage. Well, when we write it out, we write 75 milliliters, and we do just a simple division, okay, and that is the part from the whole. So our part is 75 milliliters divided by 250. All right, and that gives us 0.3. Now, we don't want to work with decimals, we want to work with percentages. So we're going to multiply that by 100, and we're going to move that decimal. And that gives us 30% ethanol. And I write V over V, meaning that it's a volume, okay, over a volume, right? We're starting with a volume, and then we are comparing it to another volume, okay? And so what we're seeing here is that this concentration is now 30% ethanol, okay? Now, ethanol is found in alcoholic beverages. This is what actually makes it alcoholic. A 30% alcoholic beverage is really strong. So just giving you some perception here, most drinks are like 5%. So this is something that's very strong in comparison, okay? All right, now down below, let's talk about percent by mass, okay? So what is the percent by mass of NaCl in the final solution when 15 grams, okay, now we're working with grams, we're not working with a volume, of NaCl is dissolved in and diluted to a volume of 250 milliliters, okay? So let's put our mass of our solute is 15 grams of NaCl. Now the mass of our solution is 150 milliliters. Now here's the challenge, right? Milliliters is a unit of volume, not mass. But when you're working with water, 150 milliliters is equal to 150 grams, okay? This is only for H2O. H2O only, okay? Only with water can you do this. So now we know what our mass of our solution is. So when we calculate this, we do 15 grams of NaCl, and then we divide that by 150 grams, and that's our solution on the bottom. We don't have to necessarily particular what the units or what's in it. We just have to say it's 150 grams, and that is equal to 0.10, okay? And what we need to do is turn it back into a percentage, times it by 100, and then that gives us 10% NaCl with M over M, because now we're comparing masses, okay? So if we're looking at the mass of our solution, 10% of that is going to be NaCl, okay? So what you're doing here, okay, is you're just doing a comparison of mass to mass rather than volume to volume. Now, there is going to be circumstances where you could have mass over volume, okay? And so it's the same premise as what we're doing before. We're taking the part, comparing it to the whole, and that's really it, okay? So, and in that example would be mass over the volume, okay? You could do the same thing here. You say 10% NaCl mass or M over V, because you're saying the grams over the volume. In this situation, it could be either way, okay? All right, so just keep that in mind. All you're doing is comparing the part to the whole, okay? And then the last part is parts per million, okay? All right, there is two ways to solve these kinds of problems, all right? and I'm going to show you both ways here in this example. Okay, now we need to recognize what is parts per million. So parts per million, okay, all right, is recognized as milligrams of a solute per kilogram of the solution. All right, so these are the units that we want to be in. This is kind of similar to molarity, where molarity is moles per liter. Parts per million is milligrams of solute per kilogram of the solution. So you're taking one part out of a million. Like, it's a huge number. We're working with very small numbers within the solution, okay? This is typically used when we're looking at analyzing like water. Like if there's like a toxic mineral or trace element that's in there, even a small amount is harmful to you, okay? And this measurement is to kind of give us a number that's workable when we're working with such large numbers, okay? So in this example, all right, I'm going to show you the way that you can do it the easy way, okay? 0.0051 grams per 2,500 grams. I'm going to set this up here. So right here, we have a 25,000 gram sample of water, and is tested for arsenic and contains 0.0051 grams of this toxic element. So these are really small numbers compared to how much there actually is in this whole solution, okay? Now, you can set this up where you're doing the part from the whole, just like we did earlier. So our part is 0.0051 grams compared to the whole of 2,500 grams. And what you can do with this is just multiply it by 10 to the 6. So divide these and then multiply it by basically a million. And then that will give you a number like this. If you do it in your calculator, you type in 0.0051 divided by 25,000, and then multiply it by 10 to the 6th, and that will give me a number 0.2 parts per million, and then we can write arsenic at the end of that. Okay, so this is kind of the way to do it. If it comes in grams, well, all you got to do is divide them and multiply by a million. Now, if you have a number that starts with kilograms, or you're working with different numbers, you're going to have to do a little bit of work to get that to balance, and we use the picket fence. So down below, I'm going to show you the picket fence method, okay? Let's start out with what they're given. What's given to us? Grams of arsenic, and then we have 5,000 grams of solution. So here's our setup. This is what we're going to start with. And what we want to do is get our units to match with this parts per million on the other side. So these grams need to be turned into milligrams, and the bottom here needs to be turned into kilograms. So we need to do a little bit of converting, okay? So what I'm going to do is set this up, and I'm going to try to convert. Just we'll start with one and work with the other, okay? So 1 gram, okay, of arsenic is equal to 1,000 milligrams of arsenic, okay? We're just doing a true statement, okay? This section right here is a true statement. 1 gram is equal to 1,000 milligrams. Let me erase that, okay? So now my grams of arsenic cancel, and I now have the unit milligrams. And then now we're going to work with the bottom one, okay? So 1,000 grams is equal to 1 kilogram. And now I've got my kilogram unit set up, and those cancel across. Okay, so now I have my unit set up, and then what I'm going to do is multiply the top and then divide it by basically 25,000, and then that will give me 0.2 parts per million. Let me zoom in here, of arsenic. All right, you'll end up coming up with the same answer, but there's 2 ways to get there. So if your problem starts out with grams and grams, well, just divide them and multiply by a million. But if you're given like a milligram or a kilogram, well, now you have to use the picket fence and get your units to match that of parts per million, because parts per million really is milligrams per kilogram. And this is like the last thing in the unit. You should have a lot of practice with picket fences by now, and you should be able to follow me through this. If you're struggling with this, go watch my video on picket fences, all right, and so forth to help get you some baseline understanding of how I set this up. But we're at the very end of this unit, and I expect you to be able to know and keep up and follow with me and be able to cancel units and get them set up. Okay? All right, that's it for this video. If you have any questions, don't forget, please come talk with me and I can help walk you through it. Okay? Thanks again. Until next time.